Day 816 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3517, smallest palindromic rearrangement 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a palindromic string S. Return the lexicographically smallest palindromic permutation of S. Now, before we go through these examples, let's go ahead and take a look at these definitions. So a palindrome is a string that reads the same forward as backwards. So as you can see in this output reads the same forward as it does backwards, A, B, B, A. Similarly, in this output, it reads the same forward as it reads backwards, A, C, D, D, C, A. Boom. Then we need to return the lexicographically smallest. So it says, a string is a lexicographically smaller than a string is lexicographically smaller than a string B if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. If the first min A dot length or B dot length, so the minimum of A or B characters do not differ, then the shortest string is the lexicographically smaller one. So it's for the sake of this question, it's just really alphabetical order, right? So this is the alphabetical order palindrome, right? This palindrome is in alphabetical order. This palindrome right here is in alphabetical order. So that's what they mean by the lexicographically smallest. Then the permutation, it says a permutation is a rearrangement of all of the characters in the string. So that's just how we took this string, right, B-A-B-A-B, and turned it into a palindrome by rearranging the characters. Same thing here. We took this string D-A-C-C-A-D, which this is a palindrome as well, but we rearranged it to make a smaller palindrome. Going back to the alphabetical order, the more alphabetical order it is, the smaller it is lexicographically, right? So this would be lexicographically bigger because it starts with D, whereas here it starts with A, and A comes first in the alphabet. But now that let's go ahead and take a look at these examples now that we've went through the definition. So in example 1, our input S is equal to a string Z. Our output is a string Z. There's only one character. It says a string of only one character is already the lexicographically smallest palindrome. So we didn't have to rearrange anything or change anything because it's only one character. So let's take a look at example 2. So in example 2, the input S equals a string BA, BA, B. The output is a string A, B, 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 A. It says rearranging the string BA, BA, B to A, B, B, A gives the smallest lexicographic palindrome. So once again, we took this. This is a palindrome as well, actually, but it's not the smallest because this starts with a B when really we could make it start with an A. So that's why we return this one instead. Similarly, in example 3, we have our input S equals string D-A-C-C-A-D. The output is A-C-D-D-C-A. It says rearranging the string D-A-C-C-A-D to the string A-C-D-D-C-A gives the smallest lexicographic palindrome. So once again, this starts with a D. We know that A right here becomes before D in the alphabet, so we could make a palindrome that starts with A. Then we also know C comes before D in the alphabet, so that's why the C would come after the A, and then we have the D's, and then it's a palindrome with the C-A. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all, y'all. Now, the first thing we need to do is we need to convert the string into an array of characters and sort them. Sorting ensures that when we build the palindrome, the lexicographically smallest characters are placed first. So we're going to declare a variable, call it rstr. We'll set that equal to an array. We'll open up the parentheses, pass in S, and then we're going to sort it by saying dot sorted. Boom. Then we're gonna create another variable that stores characters that have been seen an odd number of times. If a character appears once, it is added here. If it appears a second time, it is removed from and forms a pair. So we're gonna declare a variable called r_append. R_append, and we're gonna set that equal to an array of characters. Come outside of that, and we're just going to initialize it with some parentheses like that. Boom. Now we're going to store one copy of every completed pair. These characters will become the left half of the palindrome. So we're going to declare a variable called left, and we'll set that equal to an array of character. Once again, we're going to initialize it by putting the parentheses right there. Now we're going to process each character in the sorted order. So we're going to say for I n rstr and open up the brackets. And if we've already seen this character once, we've now found a matching pair. So we're going to say if r.append dot, not dot append, but r_append dot contains, open up the parentheses, passing I. So we're going to iterate through this array right here. That's what I is going to, as we iterate through, if I matches something that is in here, then we're going to come right here. We're going to open up the brackets, and we're going to place one copy into the left half. So we're going to say left.append, open up the parentheses, passing I. Then the left half of the palindrome. Then we're going to remove the unmatched copy since the pair is complete. So we'll come underneath this and we'll say if let index equals r_append dot first index, open up the parentheses of :I. Come outside of that, we'll open up the brackets and we'll say r_append dot remove, open up the parentheses at : index. Boom. Then we're going to come right here. We're going to say else. We're going to open up the brackets. In the first occurrence of this character, we're going to save it until we see another matching character. So we're going to say r_append dot append, open up the parentheses and pass an I. Now we're going to start building the palindrome using the left half. So we're going to come right here. We're going to declare a variable called result, set that equal to left, come underneath that, and if there's one unmatched character left, it must be the middle character of the palindrome. And since the input is guaranteed to be rearrangeable into a palindrome, there can be at most one such character. So we're going to say if r_append dot is empty. We're going to open up the brackets and we're going to say result.append, open up the parentheses, r_append, square bracket 0. Boom. Now we're going to mirror the left half to create the right half. So we're just going to come underneath this and we're going to say result plus equals left dot reverse, put the parentheses. Then we're going to convert the character array back into a string by coming underneath this, and we're going to be like return string, open up the parentheses and pass in results, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted. Let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 832 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, make sure you get one more look at the code. That's the top. This is the bottom. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.